Welcome to Maths for You channel. Another past question on a trigonometry proof, proved by induction of a trigonometric equation, and again solving trigonometric equation too. Three different type of work to be done. Let's start with the first part. Part A. Show that sine 2nx equal sine 2n plus 1x cos x minus cos 2n plus 1x sine x. So we need to prove sine 2nx equal sine 2n plus 1x cos x minus cos 2n plus 1x sine x. To prove the trigonometric function or equation, it's best to reduce it. So that means we'll take the right hand side and prove equal to left hand side. So prior to do that, let me write that equation again. Sine 2nx equals sine 2n plus 1x cos x minus cos 2n plus 1x sine x. Again, as I said, we're going to take the right hand side to reduce it to equal to and prove that equal to left hand side. Before do that, we should know a trigonometry identity. This is the students should know, the A-level students should know. So what that is, sine A cos B minus cos A sine B equals sine A minus B. So sine A cos B minus cos A sine B equals sine A minus B. So if you compare our right hand side to the proof, equation proof, we have 2n plus 1x and x. So we take 2n plus 1x as A and x b. So the equation, so sine A minus B, sine A minus B. So what it is that the whole thing will become reduced to sine A minus B. A, we actually took it at 2n plus 1x and B. So sine A minus B, sine time, instead of A, 2n plus 1x, instead of B, x. So 2n plus 1x minus x. If you expand it, 2n times x is 2nx. X times 1 is x, it's minus x, plus x minus x cancelled out. What we left with, sine 2nx. This is equal to left hand side, is equal left hand side. So that's proved. So the first part is done. Second part, hence proved by induction that cos plus cos 3x plus, I should say cos x plus cos 3x plus cos 5x and so on up to nth term cos 2n minus 1x times x equal sine 2nx and 2 sine x. You can see that in a sine 2nx in that first part. So we may have to use that for this one. That is what they said, hence. So the first part, sine 2n x, and the second part. So second part, we'll have to use the first part results. So use the right hand side format. Okay, let's start the question. I'll rewrite again. Cos x plus cos 3x plus cos 5x and so on up to cos 2n minus 1x equal 2 sine x and sine 2nx divided by 2 sine x. So this is by induction. So we need to prove this by mathematical induction. So prove by induction. As usual, step 1, again, is n is an element of integer and x not equal 0. The reason why, if you look at that the right hand side, the denominator is sine x. Sine 0 is 0, so that will be undefined results. That is why they said x not equal 0. Anyway, we're not going to use that for actual working out. Right, left-hand side, n equal 1 for left-hand side. Left-hand side is only one term. What is on the left-hand side? First term is cos x. So left-hand side is cos x. Let's prove that right-hand side is cos x too. So right-hand side, we have given the equation 2nx sine 2nx divided by 2 sine x. So 2 sine 2 times 1 times x divided by 2 sine x. That is 2 times 1 times x is sine 2x over 2 sine x. Another term, trigonometric identity, sine 2a equal to sine a cos a. Again, the student should know this identity. So if that's so, instead of 2x sine 2x, we can write that into single angle format. 2 sine x cos x divided by 2 sine x. 2 cancelled out, sine x cancelled out. What we left is cos x. So the right hand side is cos x. Left hand side, we know that cos x. So left hand side equal right hand side. Step 2. For n equal k, assume that the equation is true for n equal k. So we assume that the series on the right hand side, or sum of that series, trigonometric series, equal to sine 2kx divided by 2 sine x. So that's for the k, n equal k. Now we have to prove it for n equal k plus 1 to be proven for n equal k plus 1. To do that, if you look at the series, if you look at the pattern of the series, the next term after the k term, which will be k plus 1 term, is inside a k plus 1. So that we need to add the term after the k, of course, left hand side. If you do that left hand side, and then we have to do the same thing for right hand side too. So left hand side, let's start with the left hand side first. So left hand side, cos x plus cos 3x plus and so on up to the k term, cos 2k minus 1x. That's up to that, we know that. The term after the k term, k plus 1 term, cos 2k 2 times k plus 1 minus 1x. So we have added this part to our assumed equation. So left hand side, we have that. And of course, we have to add that to right hand side as well. Before we do that, we can simplify the last term. So cos x plus cos 3x, and go up to the last term, the k plus 1 term. Instead of 2 times k plus 1 minus 1 times x, we can simplify it. 2 times k is 2, 2 times 1 is 2, and minus 1. So in other words, 2k plus 1. Instead of 2 times k plus 1 minus 1, we can write cos 2k plus 1x. Right, that's the left-hand side. So this term is added to the left-hand side, therefore assume equation. Therefore, that same term must be added to the right-hand side in order to keep this equation same. So the right-hand side, the assume part is sine 2kx divided by 2 sine x. Now the new term to be added, which was added to the left-hand side. So the right-hand side add the same thing, cos 2k plus 1x. Right, now a bit more simplification. We know for, so this is in the question they said hence, but instead of 2k and x, the first part, the right-hand side format is a 4 different format. So the 2kx, sine 2kx, instead of sine 2x, we can write the right-hand side first part format, which will be, instead of n, is here, k. So sine 2k plus 1x cos x minus cos 2k plus 1x sine x. If you want, you can actually revisit that first part, then you know exactly what I'm talking about. This is, if you look at it, this part, this sine 2nx equals sine 2n plus 1 x cos x minus cos 2n plus 1x sine x. but now it's a k, isn't it? So 2 sine 2k x equals sine 2k plus 1x, cos x minus cos 2k plus 1x sine x. That is exactly what I did here. Here, that's it. So the top part is instead of sine 2kx, written that format, the right hand side format, first part right hand side format, and the denominator 2 sine x, and plus extra part which is cos 2k plus 1x. So cos 2k plus 1x. Now we can take LCM. 2k 2 sine x is an LCM for combine the whole lot. So 2 sine x. So first part is come up as sine 2k plus 1x cos x minus cos 2k plus 1x sine x, and the third part denominator 1, so we have 2 sine x denominator, therefore you have to multiply by 2 sine x, so that will be 2 cos 2k plus 1x sine x. Simple as that. Instead of that cos 2k plus 1x, we just have another extra 2 sine x because of LCM. If we could closely look at that nominator, the first part is fine. The second part is cos 2k plus 1x sine x. And again, here, plus 2 cos 2k plus 1x sine x. So here, minus and plus. So that will be reduced to, just 2 minus 1 is 1. So we can rewrite that sine 2k plus 1x cos x, instead of minus, plus, because of 2 minus 1 is 1. So 1 cos 2k plus 1x sine x. So that's what we are writing it. And the denominator 2 sine x. Again, we used this format before, but I'll just reiterate that. Cos sine A cos B plus cos A sine B is plus here. Sine A cos B plus cos A sine B is equal sine A plus B. Before you use that the minus in between, but here plus. So again, students should know about it. If you compare that to this identity, A equal 2k plus 1x, B equal that. So we want to know sine A plus B. So before that, see what is A plus B. A plus B is 2k plus 1x plus x. So if you could expand it, remove the bracket, 2k times x is 2kx, plus 1 times x is 1x, as another x. So that is actually, if you look at it, 2kx plus 2x, which can be written as 2 times k plus 1 times x, 2 times k plus 1 times x. So the right hand side now is simplified. Sine 2 k plus 1x over sine x. So this is the right hand side is true for n equal k plus 1. He proved it for n equal k plus 1. Therefore, the actual series, trigonometric series, cos x plus cos 3x and so on up to n, the right hand side equals sine 2nx divided by 2 sine x. So by induction, we prove that. And third part, there's an equation given that to be solved. The equation is cos x plus cos 3x equal half. If you could look at our second part, that proved by induction part, there's a series, the cos x plus cos 3x plus cos 5x and so on. But we don't need to go that far. We can take the first two terms. So n equal 2, cos x, cos 3x, so n equal 2. If n equal 2, we end up with the left hand side cos x plus 3x. But the right hand side, of course, we have to use n equal 2. So sine 2 times 2x divided by 2 sine x. That will be sine 4x. 2 times 2 is 4. Sine 4x divided by 2 sine x. Again, we use this sine 2a equal 2 sine a cos b. There's another trigonometric identity you should know. But we have sine 4x. We can split that into, say, this one is sine 2 times 2x and 2 times a. So this can be a. So so we can write sine 4x in the term of 2 sine 2x. So it's because of its a is 2x. So 2 sine 2x cos 2x. But sine 2x, again, you can reduce that sine 2x, the sine 2x into single angle format. So 2 instead of sine 2x, we can write 2 sine x cos x times cos 2x. So it will be, so this cos x plus cos 3x on the left hand side now become 2 is 4 sine x cos x and cos 2x divided by 2 sine x. Sine x cancelled out. The 2 and 4 common 2 is 2 left. So what we have is 2 cos x cos 2x. Cos 2x can be written in the single angle format. Cos 2x equal 2 cos squared x minus 1. As again, is another trigonometry identity students should know. The cos 2x equal 2 cos squared x minus 1 as a trigonometry formula, trigonometry identity. Now we can apply that. So what we have, the cos x cos 3x, the left hand side, we just keep writing it. But the right hand side, cos 2 cos x 2 cos x. Instead of cos 2x, we will write 2 cos squared x minus 1. Now, simplified, 2 times 2 is 4, cos times cos squared is cos cube x, minus 2 times 1 is 2, minus cos x. So what we have, cos x plus cos 3x, is that's the equation. So the left hand side, or rather just left hand side, is now becomes 4 cos cube x minus 2 cos x equal half. So it just, this is the new equation, or the same equation, but it's a different format. Here, if you could multiply by 2 both sides, if you multiply by 2 both sides, if you look at multiply by 2, and then this will come 4 times 2 is 8 cos cube x minus 2 times 2, 4 cos cube x equal 2 times half is 1. So 8 cos cube x minus 4 cos x minus 1 equal 0. Instead of keeping in the cos format, we can simplify it, because we can look at it as the polynomial function in cos. So we let cos x equal y. If that's so, 8 cos y cubed minus 4y minus 1 equal 1. So it's the polynomial, or third cubic function or cubic equation in y. So let's find 3 values, or 3 roots, because of y to the power of 3. So 3 roots we expect. Just the first root, we can use a sort of the substitute values to y and find the value which satisfy the equation. If you look at 8y cubed, 8 and y cubed is some sort of a relationship with 2. This is 2 to the power of 3 is 8 y cubed. So it's just looking for y is similar, something to do with 2. So if we say y is 2, that would be 2 cubed is 8, 8 and 6, 4 is well out. So it can't be just 2. So it could be, or will be, either half or minus half. Let's look at half. Y equal half. So if you substitute that, 8 and half time cube is 1/8, minus half time half minus 1. So 8 cancelled, and that minus 2 is not equal 0. So obviously y equal half isn't the root. So let's try y equal minus half. Then if you look at it, minus 8 times 1/8 plus 2 times half and minus 1, that is equal. This is because of 8 times is 1. There's 2, minus 1 plus 2 and minus 1. That is 0. So y equal minus half is one of the root. So if that's one of the root, y equal minus half. So y plus half is a factor. It's a factor of that function, the cubic function. So the one factor we know, so we are looking for two factors. So to find that, when we have two factors, means we are looking for a function, is a quadratic function. So in order to get that quadratic function, we should go for, there's another way, but we should go for long division. So what we need to do is y cubed is 8y cubed minus 4y minus 1, and then divider is y plus half, because y equal minus half, so y plus half is as a root, one root. So we dividing that function with the linear root. If you do that, y plus half, and then y, we need to get 8y cubed. That means 8y squared. So 8y squared, the first term. So 8 times 1, y squared times y is 8y cubed. And then 8 times half is 4. 8 times, y squared, so 4y squared. If you subtract that, the plus 4y becomes minus 4y squared, so minus 4y squared, and then minus 4, if we could bring that minus 4 down, minus 4y. Then we're looking for it to equate that minus 4y squared. So what that is, 4y. If you could put 4y minus 4y. So minus 4y times y minus 4y squared. Minus 4y times half is 2y. Then subtract that y squared terms cancel out. 2y minus 2y become plus 2y. So minus 4y plus 2y is minus 2y. Then minus 1. Then looking to eliminate that y. If you do that, that's 2, minus 2. So minus 2 times y is minus 2y, minus 2 times half is minus 1. So that's all kinds, that's no reminder. Of course, we are not expecting a reminder because of y plus half is a factor. So now the function become more simpler. The first factor, y plus half, and the second order or quadratic function left with is from the value from the long division, which is, or the function from the long division. 8y squared minus 4y minus 2 is equal 0. That's what we have. Right, let's simplify it more. Y plus half and 4y squared minus 2y minus 1. We need to find the factors, root of those y. So first root is y equal minus half, we already know. The second root for quadratic function, quadratic formula, we could use it. So minus b plus or minus root b squared minus, so minus b plus or minus root b squared minus 4ac divided by 2a format we use it. If we use that, y equal to the b is minus 2, therefore plus 2, plus or minus square root 2 squared or minus 2 squared 4, plus 4a is 4, 4 times 4, c is minus 1, therefore the middle plus. So what we have, 2 plus or minus, and we can take 4 out, that will be 2 outside the root sign. So inside 1 plus 4, so that is 5. So and then again the denominator 2 times 4, 2 cancelled out. So what we have, 1 plus or minus root 5 divided by 4. So we have all three roots. The first root is y equal minus half. The second root, just 1 plus root 5 over 4. The third or final root, 1 minus root 5 over 4. So these are y values, but we took y as a cos x. So in other words, the values for cos x is minus half 1 plus root 5 over 4, 1 minus root 5 over 4. Now you have to use a bit of a calculator work. The cos x equal minus half, therefore x equal the cos inverse minus half is 120. You should know, otherwise you could use the calculator. So it's 120. 120 in the term of pi is better. So 2 pi over 3. So first value, x value, is 2 pi over 3. Second, that's what we asked to find, the values. The second one, 2 pi over 10, because of when you look at use the calculator, the value for work out that 1 plus root 5 over 4 and then cos inverse, it will give you 36 degree. 36 degree is 360 by 10, isn't it? So 360 by 10, 360 is 2 pi over 10. This look better if you use it pi format. Again, 108. Again, you can work it out in the pi format, 6 pi over 10. The 3 times, if we look at it, 36 times 3 is 108. So 2 pi over 10 times 3. So it's 6 pi over 10, or 3 pi over 5. But just leave it as 10, it'll be better. So the values for x is 120, 36, 108. But it's an extra, that we can stop it there, but extra bit of info for students. When you do that, say sometime if the range is longer range, say 0 to 720 or whatever, then you can get the repeat values. But here it's only one value. So we just, if we use always the pictorial is a lot better than the writing down. So it's a pictorial. So this is a cos function. They have a cos curve or cos waveform. If you look at it, then you can mark it out. It's only 0 to 180 or 0 to pi. 0 to pi. So it's just first value, 36, is between 0 and 90. The second value between 90 and 180. Third value 120, between 90 and 100. All three values. Thank you. Please subscribe to the channel and send me similar question for me to make more videos on your question. Please comment me. Thank you for that. Please also select auto notification. Thank you.